So to overcome the weaknesses used in Diffie-Hellman and to retain the advantages, internet key exchange is used, and it uses some of the prominent features, and we'll look at the features of internet key exchange, key determination. So basically there are five important features. Number one, it uses cookies to thwart clogging attacks. As I told you, clogging is the hacker who has come into the vicinity asking for keys again and again, and more than number of times you ask, more exponentiation algorithms and modulus operations happen, and therefore the computation may become intensive, and therefore it can kill time. Therefore, to overcome this and to avoid jamming, we need cookies. So cookies are used in internet key exchange algorithms procedures. So how it is done? It enables the two parties to negotiate a group, that is, it specifies global parameters. So the two groups, user A and user B, are sharing the parameters which are globally shared, and at the same time that is the second feature. So parameters here are defined as globally, and it uses nonce to ensure against replay attacks. So replay attacks should be overcome because that was one of the reason for clogging, and it is possible by using nonces. What is a nonce? It is an arbitrary number used for communication. So once the key has been asked, that procedure or that communication is indicated with a unique identity number. And again the same procedure happens, it will immediately identify that this is a replay attack. Therefore, nonce help in avoiding the replay attacks. It enables the exchange of Diffie-Hellman key values. Therefore, as a result, it is possible, and it also authenticates the Diffie-Hellman algorithm to thwart man-in-the-middle attacks. Therefore, since cookies are used and global parameters are used and nonces are used, it is possible for us to overcome the clogging attacks and replay attacks, and as a whole, man in the middle attack, that is the attack which is happening in the network layer, is avoided. How to avoid clogging attacks? So as I told you, cookies are helping in order to overcome the clogging attacks. A cookie, each side sends a pseudo random number and a cookie in the initial message, which the other side acknowledges. So initially when you are sending, a pseudo random number and a cookie is sent to the recipient, and that also responds. It also acknowledges. So this acknowledgement must be repeated in the first message of the Diffie-Hellman key algorithm exchange, and if the sources are not forged, the opponent gets no answer. So sorry, if the source address is forged, then you get no answer. Otherwise, if it is clean, it is not forged, then there is a response or an acknowledgement. By this you can find out there is a attack or not. So it is a mandatory to generate the cookies, and therefore three basic requirements are satisfied. So the cookie must depend on the specific parties, so it prevents attacker from obtaining a cookie which avoids attacks. So once if you're taking a cookie, it is, you are a legal person. If you're not accepting for cookies, you are illegal, you are scared. It must not be possible for anyone other than the issuing entity to generate cookies. So cookies will come only if you are authenticated. So it means that it, you should be an authenticated person to generate as well as to receive. So the cookie generation verification methods must be fast to thwart attacks. It should happen swiftly in order to overcome the attacks. So IKE not only overcomes the attacks or whatever is happening on the internet, it will also ensure authentication is taken care by following these three procedures called as digital signatures, public key encryption and symmetric key encryption. In digital signature, the whole of the content is attested with the digital signature, or in other words it is the hash value. So that is ensured in internet key exchange algorithm. And next, public key encryption. So the exchange is authenticated by encrypting parameters such as IDs and nonces with the sender's private key. Along with the private key, some information if you are sending, like the ID and the nonces, they are all encrypted and they are authenticated. So it is generated from a right source. So the information of the ID and the nonces are encrypted along with the private key. Private key. Symmetric key encryption. Here a key is generated which can be used to authenticate the exchange of symmetric encryption of exchange parameter. So this also helps in authentication, and it takes care to see that it is originated from the right source. Yes, IKE versus V2 exchange. Okay, IKE V2 exchanges. So the internet key exchange V2 protocol, version 2 protocol involves the exchange of messages in pairs. So they have to do the exchange using pairs itself. So the first two pairs of exchanges are referred to as initial exchanges. So two pairs of exchange has been done, and the first one is called as the initial exchange. First exchange is done between two peers with content being about cryptographic algorithms and other security parameters. So when the first exchange happens, they share the information between two peers. That is, both of them should be of the same level. Both of them should be of the same strength of possessing their identity, and the information they share is about which algorithms they are using for cryptography and for other security parameters. The outcome of this is to set up a special security association called the IKE Security Association, which defines parameters for a secure channel. So a special IKE security association is being created by doing so, which defines parameters for a secure channel. So what are the parameters required for secure channel has been in this IKE security association. Then the two parties authenticate one another and set up IP security association, which is placed in the SADB and used for protecting ordinary communication. So by doing so, the two parties are authenticated by one another. Both of them are very much into the very much fine, and they set up IP security association, IPsec security association. Another security association is created, which is placed in SADB and used for protecting ordinary communication. So ultimately, by providing multiple security associations, it is possible to protect the communication. So this is how the information exchange is being done, and this is the short code about how the things go on. So initiator and the responder. So these are the information sent, and in response the information is being sent back. So this is how the information exchange happens between the two people who are into the transaction or communication, peer level transaction. So header and payload formats. IKE defines procedures and packet formats to establish, negotiate, modify and delete security associations. Yes, they have their standards and that has to be followed. So these payload formats provide consistent framework independent of key exchange protocol encryption algorithm. So whatever the payloads formats has been provided, that is independent of key exchange protocol. It doesn't suit with this protocol. Not necessary to follow the rules and regulations of the protocol meant for key exchange, and also for encryption and also for authentication. So they are independent of all these things. This is how the IKE header format appears like. An IKE message consists of an IKE header. So this is the header version. So initially the whole of the information is provided with a header, followed by one or more payloads. So below these are the payloads. So what are the contents in the IKE header? First is the SPI, Security Parameter Index. So it has to have the information of indexing, a value chosen by the initiator to identify a unique IKE security association, a number chosen. So that is the carried number. It carries away with this number identity. Followed from this, we have in the bottom layer as responder SPI.
a value chosen by the responder to identify a unique IKE security association. So both of them have to share the numbers, initiator as well as the responder. What is that number? SPI number. What is this SPI? SPI number is in association with the IKE security association. And followed with that, this is the whole of the information which carries in between the layers. One is the next payload. Indicates the type of the first payload in the message. So what is the first part of the message? This is comprised of 8 bits. This is comprised of 8 bits. Next you have major version, indicates what is the major version and minor version. Next, exchange message, indicates the type of exchange. What do you want to exchange? Is it the key? Is it the specific public key or the private key? And is it the message? Such informations are being exchanged. Followed by flags. So what exactly flags have? It is an 8-bit, indicates specific options set for this IKE exchange. 3 bits are defined. So the initiator bit indicates whether this packet is sent by SA initiator or not. The version bit indicates whether higher major version can be used. The response bit indicates whether it is the same message to the message containing the message ID. So these are the information which is carried by the flags. Three bits are defined. One is the initiator bit indicating the SA initiator. It is sent by him or not. To convince, you need to prove yourself that whether this information is sent by the security association. So 1 or 0. Next it indicates the version. Next indicates the response bit, whether it is for the same message for what you are sending. Next we have the message ID, which is used to control the retransmission of lost packets and matching of requests and responses. And finally the length of the total message, that is header plus all payloads, and it is in octets. So this is of 32 bits. We'll now look into the different types of IKE payload, how it is categorized. All IKE payloads begin with the same generic payload header as shown. So all the while it has a header, and followed with the header you have the payload. So the next payload field here has a value of 0 if this is the last payload in the message, else its value is the type of the next payload. So if it is 0, if the value is 0, there is no other payload back. This is the last part, last bit of the information. The payload length field indicates the length in octets of this payload. How much is the length of the payload? It is displayed in octets in set of 8 bits. C is equal to critical bit is equal to 0. So if the bit is 0, if bit is set to 0, if the sender wants the recipient to skip this payload. If it is equal to 1, if sender wants the recipient to reject entire message. So what is this C playing here? It is an 8-bit information. What exactly it does here is, if this is set to 0, the sender wants the recipient to skip this payload, skip. Otherwise, if it is equal to 1, the sender wants the recipient to reject entire message. So you can skip or reject the message based on the value allotted here as 0 and 1. So this is one type of IKE payload. The payload has a complex hierarchical structure. Payload may contain multiple proposals. Each proposal may contain multiple protocols. Each protocol may contain multiple transforms, and each transform may contain multiple attributes. So what are all these things? What do you mean by proposal? What do you mean by transform? What do you mean by attributes, etc.? We need to understand. So these elements are formatted as substructures within the payload. What do you mean by proposal? This substructure, so it forms a complex hierarchical structure, one below the other. This substructure includes a proposal number, a protocol ID, AH or ESP or IKE, an indicator of the number of transforms, how many transforms it has undergone, and then a transform substructure. What is the type of the transformation it is done? So that is the information contained in the proposal. So it contains the entire information, what is the protocol used, But here we say each proposal may contain multiple protocols. So what is the protocol, what is the protocol ID, what is the number of transforms it has done, and how exactly is the substructure of the transform. What exactly is there in the transform? Each protocol may contain multiple transforms. So what is a transform all about? Different protocols support different transform types which define cryptographic algorithms to be used with a particular protocol. So different versions. Transform means nothing but the way it is represented. For that particular representation, you need to have a respected cryptographic algorithm. So that is the information stored. And in attribute, these modify or complete the specification of the transform. So what exactly is the transform length? Example, key length, that is considered as an attribute here. IKE payload types. Different types of IKE payload: security association payload, key exchange, identification, certificate request. These are the different types. And the parameters: security association means proposal, key exchange means what type of algorithm are you using, how is the key exchange, identification ID, certificate cert encoding, certificate data, authentication method and the data which you have used. So I think most of them are quite clear here. So you can go through this, and these are the different types of IKE payload types, and their respective parameters on the right hand side of the column. We need to understand each one of them. First, key exchange payload. What do you mean by key exchange payload? So this is the information of the key exchange. Can be used for a variety of exchange algorithms like IKE, DH or RSA. So these are the different algorithms meant for key exchange. Data field contains data required to generate a session key. Next type is payload identification, used to determine the identity of communicating peers. Who are the people? Identification. You need to have the ID for the two people who are in the peer level. So also for identification, data field contains IPv4, IPv6 address. So the data field here is represented in terms of IPv4 or IPv6 address. Certificate payload transfers a public key certificate. This field indicates the type of certificate or certificate related information. Any information related to the certificate is present in that particular space meant for certificate payload. So PKCS #7 wrapped X. Okay, different types of certificates. PGP certificate, DNS certificate. These are the different types of certificates which are present in the certificate payload. Next, certificate request, requesting for certificate. Authentication, which are the algorithms meant for authentication, contains data for message authentication purposes. Usually it is RSA, shared key and DSS. So digital signature algorithm. Nonce. This payload contains random data to guarantee actively during an exchange to protect from relay attacks. Yes, as I told you, a number which will have a sequence like number which avoids the replay attacks. Notify. Payload contains either error or status information associated with SA. So it gives a status notification whether it is erroneous or not erroneous. Delete. Payload indicates one or more security associations that the sender has deleted from its database. So if it has been deleted, associations with the security associations, if it is combined and it has been deleted, that information is stored. Vendor ID. Payload contains a vendor defined constant which identifies and recognizes remote instances. Traffic selector. This payload allows peers to identify packet flows, how exactly the packet should go, so that if there is a huge traffic, you shouldn't take that path. So the path for the packets to flow is decided on the traffic selector payload. Encrypted payload. This contains payloads in encrypted form and similar to ESP. Yes, encrypted data. It can include an IV if the encryption algorithm requires it, and an ICV if authentication is selected. So what exactly is the content present there? Encryption algorithm, and first time if you are doing, you need to have an initialization vector, or if authentication is there, then ICV is used, cryptographic crypted vector. Configuration payload. This is used to exchange configuration information between IKE peers. Extensible authentication protocol allows IKE security associations to be authenticated using this particular protocol. So these are the different types of IKE payload messages.